Hello friends, welcome to Nel Electronics. Resistance is one of the most widely used components in electronic and electrical engineering. Think of electric current like water flowing through a hose. The next time you want to water your plants, pay attention to the water flow inside the hose. When you press your foot onto the hose, less water comes out. The more you increase the pressure with your foot, the less water flows out of the hose. The effect of resistance in circuits is much like this pressure from our foot on the water hose. When the resistance value is greater, it's akin to exerting more force with our foot on the water hose, causing less water to exit the hose. Correspondingly, a smaller current passes through the resistance. Hence, resistance is employed to regulate the flow of current in circuits. The values of resistances are expressed in ohms. For example, a resistance of 100 ohms, 470 ohms, and so on. Its circuit symbol is shown in the picture. Additionally, resistances are denoted by the letter R. If the resistance value is greater than 1000, the value is divided by 1000. So instead of expressing it in ohms, it's presented in kilo ohm. For instance, we never say a resistance of 1000 ohms. Rather, we say a resistance of 1 kilo ohm. A resistance of 4700 ohms is also represented as 4.7 kilo ohms. Now, if the resistance value exceeds 1 million ohms, it's divided by 1 million. So, instead of expressing the value in ohms, it's indicated in mega ohms. For instance, we never say a resistance of 1 million ohms. Instead, we say a resistance of 1 mega ohm. A resistance value of 1,500,000 ohms is incorrect. It should be stated as a resistance of 1.5 mega ohms. Resistors with color bands are equipped with color-coded markings that allow us to identify the resistance value. On the body of most color-coded resistors, there are 4 color bands, one of which is farther apart from the rest and often appears in a gold color. This is referred to as the fourth band. In order to read the value of a resistor from its color bands, it's preferable to position the resistor in a way that the gold color band or the fourth band, which is farther apart, is on the right side for us. We do not use the fourth band when reading the resistance value. There are several color codes that are numbered from 0 to 9. Black, brown, red, orange, yellow, green, blue, purple, gray, white. These colors are respectively associated with the codes 0 to 9. In other words, the color black corresponds to the code 0, brown to 1, red to 2, orange to 3, yellow to 4, green to 5, blue to 6, purple to 7, gray to 8, and white to 9. Now we want to read the resistance value from these color codes. The first band indicates the digit of the tens place, which in this case is brown in color, representing the code 1. Therefore, we note down the digit 1 in the tens place. The second band represents the digit of the ones place, and in our example, it's black in color. Black corresponds to the code 0, so we write down the digit 0 in the ones place. Lastly, the third band determines the number of zeros that come after these 2 digits. In our example, the third band is red in color. which has the code 2. Therefore, we need to add 2 zeros to the right of the 2-digit number we've noted earlier. As a result, the resistance value in this example is 1000 ohms, equivalent to 1 kilo ohm. Now let's read the value of another resistor from its color codes. As I mentioned before, we don't consider the fourth band, the gold band, in our calculations. You can see the color codes in the left side of the image. The first band is blue in color, corresponding to the code 6, so we note down the digit 6 in the tens place. The second band is white, indicating the digit 9 in the ones place. The third band specifies the number of zeros and is brown in color. Since brown has the code 1, we add 1 zero to the right of the digit that we've written. Therefore, the value of this resistor is 690 ohms. However, what about the fourth band? I mean the gold band. This band indicates the tolerance value. If the fourth band is gold, it signifies a tolerance of 5% for the resistance value. In other words, in this example, the resistance value is 1 kilo ohm, and the gold band indicates that this value is not precisely 1 kilo ohm, but rather falls within the range of 950 to 1050 ohms. As a final example, let's calculate the value of the resistor shown in the picture. The first band is brown, so we write down the digit 1. The second band is black, which corresponds to the digit 0. Finally, the third band is yellow, and we need to add 4 zeros to right of the digit we've noted. Therefore, the value of this resistor is 100,000 ohm, or better expressed as 100 kilo ohms. I hope the content of this session has been useful for you.